So here we go. Basic properties. Basic properties of probability and notation is what the first exercise is about, which really just hits, it's all in that one dot point. They're really, when they say here, including the concept of random variable as a real function defined on a sample space, and examples of discrete and continuous random variables, that is really just, it's a fancy way of saying, do you know the difference between discrete, continuous, and you do, in the sense that there is a difference between selecting, let's say, the chances of choosing your favorite color versus choosing the chances of you cutting a string exactly 1.21 centimeters. You do know the difference between categories, like if you're naming something that is a number or not. It's all intuitive in this sense. You're learning to use a sample space to list out your answers. So if I said, what's the chance of you rolling a dice? I mean, the possible outcomes of rolling a dice, you'd say there's 1, 2, 3, 4, 5, 6. So you know it's numerical. If I said, what's the chance of you, like what are the outcomes if you flip a coin? You say heads and tails. That's not numerical, it's categorical. So you do know it, you just haven't put a name to it. And that's what this first dot point is talking about. Can you list out your outcomes and using the possible outcomes to find out your probability, or hence solve problems? Okay, that's what the first point is talking about, and that's what you're really doing. So let's have a look at first point. Year 11 terminology. Let's recap. What is a set or an event? We use this terminology a lot when it comes to probability. What is a set or an event? If you had to describe it to me, Stuart, what is a set? Set of numbers. Yes, that is good, but you're using the word set in it. I want another word for set. Yeah, a group of numbers, a collection of things. Doesn't have to be numbers. A set is just a collection of things. We also call that an event. So in year 11 and 12, we now move away from sets and we call it an event. So it's something that happens. Okay, it is a group of things, or a collection of things, usually denoted with a capital letter. Okay, so last year I would have taught in year 11, I said if you wanted to note a group of things, we use a capital letter, not a lower caps letter, but we use a capital letter, and we use those squiggly brackets, which we call braces. So in this example, I'm saying in the group A, or set A, or event A, it has the numbers 2, 5, 8, and 10. And that is exclusively to the group A. That's a set A. Okay, yes?
So an event be like a collection of probabilities?
Yes, it could be. It needs to be defined in that way.
Okay.
Yeah, so you would say group A has a set of probabilities, 0.2, 0.3, point, whatever it is you want to call it. So okay, it's a collection of things. It doesn't have to be numbers. It could be black, red, white. Okay? And another example is, let's say B is all events, even numbers, sorry. Okay, so you can even describe your sets. You don't have to actually write the numbers, you can describe your sets. It could be all numbers 3 greater than 3. Okay, so it's a description of a group of things. Okay. Next one, what is an element? So we've got a set. What's an element, Herbert? Yeah, it literally is anything or a thing in a set. So I said a set is a group of things or a collection of things. Then those things are called elements. Okay, so for example, the one we had above, A, the elements of A would be 2, 5, 8, and 10. The elements of B would be 2, 4, 6, 8, and it goes on to infinity. Those are elements. Elements are things within a set. Okay, so anything that you group together, that's called an element. Okay? Then what does it mean when you ask, what is a universal set? What is a universal set, Corinne? Yeah, it's all the possible elements in a given scenario. And now in that scenario, that means you can have infinite sets. Okay, you can have infinite sets. It doesn't matter how you want to group sets, but when you're talking about a universal set, it encompasses everything. A universal set has all the sets, if you think about it. Okay? Yes?
In an exam, would we ever be asked to define like one of these kind of things like element concepts?
No, but they will use the symbols, so you need to understand what the symbols mean. Yeah.
Say you had a set of probabilities.
Yep.
Could you have a probability of having a probability?
Yeah. That's potential. It could be a question that talks about probabilities. So chances of getting a chance. I haven't seen that question, but yes, you can. You can do that. You can have a probability within a probability. Yeah. So a universal set describes all the possible elements in a given scenario, and you can have as many sets or events in a given universal set. What do I mean by that? Let's say, I give you an example. Let's say rolling a dice. If I said rolling a dice, what are my total, or what's my universal set in this case? Well, all the elements that I can have in a rolling a dice would be 1, 2, 3, 4, 5, 6. Now that symbol I've used there is the symbol for the universal set. Sometimes you might see it like written short like that. Okay, but normally properly, you do a bit of a swirl. That's how I normally do it, sort of a bit of a swirl just to show that it is the universal set. And I'm saying that it has, whoops, I should do this with the braces there. 1, 2, 3, 4, 5, 6. So that's all the elements I could have, yes? Is the... No. Because the sample space I could have, for example, here, my sample space there is 2, 5, 8, and 10. Unless you're talking about a given scenario, so rolling a dice, and I said, what's the sample space? Yes. So if you're talking about a sample space of a problem, yes, that would be the universal set. But the sample space could be of a particular event or a set, not necessarily the universal set. Okay? So the example is, let's say I've got 1, 2, 3, 4, 5, 6. That's my total elements. Then I could say set A is 1 and 2. I could say set B is 1, 3, 4, 5. I could say set C is nothing. I could say set D is, I don't know, let's just say 1. I could say set E as 4 and 6. So you can see I can have as many sets as I want within the universal set. The universal set is everything that you could have, and all the sets that you want, how you want to group it, that's dependent on you. Okay, so if you think of visually, what I've just illustrated here, universal set is the entire rectangle. So it has 1, 2, 3, 4, 5, and I'm missing a 6, which I'm going to put a 6 somewhere. Okay? And therefore, this is my universal set. The rectangle represents my universal set, and all these circles are your sets. These numbers are your elements. I can have as many sets as I want. I could call this a set. I could say that's a set. I could make that a set. I could make that a set. I could make this a set. It doesn't matter. So I can have infinite sets within my universal set. The universal set is the rectangle. Okay? So that's the idea when you use this symbol. That's what we're trying to illustrate. We're trying to say that the universal set encompasses every possible element and set that you could have. Okay? So, the next one, what is a complementary set again? What is that, Akel? What's a complementary set? Oh. Yeah. Informally, we normally say it's the opposite. The way I like to think about it is it's every element that is not in the set you're looking for. So if I said, and it's denoted with a dash or a prime is what we call, so a dash. So if I wrote a dash, then what it means is I don't want, or I want elements that are not A. That's what I want. That's what a complementary set is. So if A was 1 and 2, in this particular example, if A is 1 and 2, then in this universal set, I just want numbers that are not 1 and 2. Well, what numbers are those? You got 3, you got a 4, you got a 5, you got a 6. And that's why a complement is 3, 4, 5, and 6. You're just saying, I don't want A. So that means if I actually got A plus A dash, that should equal to my universal set. Whoops. Which makes sense, because if you took A and then you add everything that's not A, well, of course you get everything. So hence that gives you your universal set, which is why it leads into the properties like probability of A plus probability of A dash should equal to 1. Of course, because you're covering everything. So of course it's 100%. Okay? Now, is there something confusing? Did I do something wrong? Oh, you're right too. Thank you. Yeah. Anything else? All right, cool. So that's your year 11 terminology. I'm just quickly going through the what a set is, what is element, what is the universal set, and what's a complementary set. Yeah. Then this is the example. So we've got A. I'm going to call A, which is a set out of your universal set. A is 2, 4, and 6. B is 3, 4, 5, and 6. I'm going to illustrate my diagram. Here's my Venn diagram. So A is 2, 4, and 6. B is 3, 4, 6, and 5. The one thing I want to remind you as well, in terms of revision, the notations, the symbol here. What's that symbol called again? Union. What does union mean? Together, to unite. And I want you to remember that because it's a common question I normally get in the exams from students. They forget the difference between union and intersection. Union just means to put together. So if I got, this is my A, and that's my B, well, I'm just going to put them together. I've got 2, 4, 6, put in together. I now have 3, well, I already got 4, so I don't need to count it again. I've got 5 and I already got 6. So together you got 2, 3, 4, 5, 6. So that's what union means. This one means intersection. Intersection, another way of understanding intersection is what's in common between A and B. So if you look at your sets, set A and B, without looking at the diagram, well, what's common between A and B? Well, clearly B and A don't have a 2 and a 3, but they both have a 4 and a 6. So it makes sense that the intersection of what's in common is 4 and 6. Which is why in your diagram, when you draw it, they overlap at 4 and 6 because they both have that shared. That's what's in common between the two. Whereas union would describe the entirety of A and B together. And therefore, that means I can use the notation that I've just learnt so far, or you've learnt in year 11. I can say then that means A union B complement, which means I want A union B, so everything that is together with A and B, and then putting a dash on that or a prime just means I don't want that. So the only thing that doesn't have 2, 3, 4, 5, and 6 is 1. Okay, so I want you to sort of get used to that notation, the language of the mathematics here. We're just saying, you know, I could actually even describe, what if I wanted to describe just that region? Then I'd say, I want part of B, but I don't want it to be part of A. So you'd say, I want what's in common in such that it's not A. So if it's not A, you got 3, 5, and 1, but 3, 5, and 1, what's in common with B? 3 and 5. So I will get only that section. If that's hard for you to understand, then write down A dash. See, A dash is 3, 5, 1. B is 3, 4, 5, 6. So if I wanted just 3 and 5, it's clear That's the intersection. If that is easier for you to understand. So you I find some students may like listing out your elements visually, and then you can see it. I'm more of a visual learner, so I like to draw it and I can see it. Okay, so for me, I'm more of a Venn diagram person. So for you, you might be a number person. I don't know. So it depends on how you're listing it. But my point is, you have to understand the notation. Okay, the notation is very important. All right. Now, the last one, just to add on in terms of your diagrams, what's mutually exclusive mean again? What's mutually exclusive? There's only one real definition for it. It's very simple. What does it mean? Yes, Jonathan? Yeah, literally. So when you have to write the definition, it just means A intersection B, and notice the notation I wrote here. I didn't do 0, because 0 by definition means that they have the number 0 in common. You have to use what we call the null symbol. That means there's nothing in common. So right here I'm saying mutually exclusive just means when there is no intersection between two events, A intersection B has nothing in common. Okay. Yes?
Did you also do the symbol where you just draw two brackets without something?
Use braces?
Yeah, but not like the empty set with just two brackets and nothing.
Yes, that is perfectly fine as well. So instead of that, you could have had just the squiggly brackets and nothing inside. Okay, so that would mean null as well. Okay, sort of like the notation I used for C just now. So if you look at C, I used the null set there. Okay, so for C. All right, now, so we've just described and went through a couple of definitions. In terms of notations, we're talking about probability now. So now we've learnt notations, we've learnt sample space. Then the next part is you're then going to talk about, well, how you're going to apply these notations to probability. Now the one I've just written up here, I just want to describe the notation. Okay, it's not that you don't know what this is. I'm sure if I asked you, if we flipped a coin, what's the chance of getting heads? You'd know. You can say there's 1 out of 2. And so you can say favorable outcome out of the total outcome, right? But what I want to focus on is this notation here. Just to remind you, the letter N represents or means the number of elements. So it means the number of elements in, and that symbol here, too much chatter today. Like I said, if you don't want to be here, just get out. I know it's just a revision, but by the time I move on to something hard, then you'll be like, I don't understand this. And the only reason why you don't understand is because the simple stuff you don't get. You think you get it, but you don't. That's why I'm covering it. Otherwise, I can jump straight to the exam question and say, do this. Which I will do it later, and if you can't do that question, it shows how much you don't understand probability. Okay, so it's going to be VCAR questions from 2008, 2011. It's pretty recent. And if you can't do those questions, it tells you, not me, tells you how much you don't understand the basics. Okay, so if you want to deal with this, do it. And then listen. Or just get out. And if you think you're capable, go out. Learn on yourself. If you're capable, do it. I don't mind. That symbol there means number of elements in universal set. And then obviously up here, you're saying the number of elements in the set of A. Okay? And then this M and N you don't really need. It just means a number over a number. And that gives you your probability. Okay, so M and N is just a number. PR is our way of saying probability of A. Sometimes I've seen my year 11s, or from last year and my year 11s this year, writing the probability. They do this. And that tells me they haven't yet learnt the notation. It just means when you do PR of A, it just means the probability of A is. That's what you're really saying. Okay, so if I did PR A equals 0.25, it just means the probability of A is 25% chance. Okay? Sometimes I see students doing this. And I don't understand. Is that notation doesn't make sense. And I know it's a small thing, but it's a big thing when you're doing that in an exam. Okay, so PR means probability, and writing the event or the set just means the probability of whatever the set is or event is equal to. Yes, Roberto?
Could be the probability 0.25.
Yes, that could work. So if 0.25 was defined initially as a name of something, so I could say the probability of, I don't know, Jess. That could be something. Okay. Unlikely, but you have to define it. Something in the question had to be defined. Okay. All right. Now, these are all the properties that describe. So if you understood probability, which you would, you know there's maximum chance into a scale of maximum chance is 1, 1, which is 100%, which is why it says all probabilities always have to be greater than 0. You can't have negative probability chance. So it's between 0 and 1. And this symbol here, oops, this symbol here is what I'm interested in. Anyone know what that symbol means? So A, Audrey? Subset. Okay, so subset, what does subset mean? Subset just means a part of, which makes sense because if this is the universal set, then of course set A is a part of the universal set. Okay, so that's all it means. This symbol here just means a subset or a part of, if that helps you to remember. Okay, and the rest of it is pretty straightforward, but the one thing I do want you to focus on is this. It's called the addition rule. And a lot of students forget this when it comes to the exam. And it's because they're memorizing this, but if you think about it logically, A union B, which I showed you before, we were able to say we can look at a diagram and answer the question, but this rule just comes from that concept. Now let me show you what I mean when we did it before over, not here, we did it over here. See over here, when we did A union B, you don't have to memorize this formula where it's probability of A plus probability of B and then minus the intersection. You don't have to do that. See, logically, you can see that. See, if I said A union B, A is 2, 4, 6, and then we said combine that with B, which is 3, 4, 6. See, the problem is if you did probability A, probability B, of course, you got 2, 4, 6, 3, 4, 6, but then what's the problem? There's a repetition of what's in common. So it makes sense that you say minus what's in common when you've got a 4 and a 6. 4 and 6 is what's in common. Therefore, do not repeat what you already have. So it makes sense that you then get 2, 4, 6, and 3, and there's a 5 that I was missing somewhere. But you see that you don't have to memorize that rule. And the interesting thing is I will get that question over and over. Students will say, what is the rule again? Addition rule. How do you do it again? Is it add, times? Why do you have to question that? Shh. You don't have to question that because if you understood it, it's just a notation to describe what you're trying to say. Okay? So you got your addition rule. And then we're heading on to the next part, column maps, how to name each region, which again, I sort of touched on that before, where I was talking about this region being A dash intersection B. You do have to know these notations. You have to be proficient in reading these notations, describing where you want the region. And why do you need that? It's just a tool so that you can use cardinal maps to answer the question. This is just another visual way of representing your data. Sometimes too much data is hard to see without a diagram or without a table, without tree diagrams. Now you don't have to use that. If you can visualize it all, you don't have to use it. But these are all tools. So you learnt this in year 11, you learnt this in year 10. It's just a skill for you to solve a problem. You don't need to use it. Okay? And that goes along with tree diagrams as well, table of values. These are all the same. Okay? Now, the reason why I'm sort of covering all this because the exam questions, you're going to use every one of those skills that I just taught you or just revised with you to answer the questions. Okay, now I'm going to jump to the VCAR exam just so you can see how knowing the basics can earn you 3 marks out of 40, and as a question 8 of the exam, it seems like it's meant to be hard, but it's not. You can do it. It's just whether you really understood the basics. Okay, so let's jump to the first exam question, just so you get a good feel. Let's start off with this one. VGUT 2011 exam 1, 3 marks, 2 plus 1, right? It's a very simple, short question. It takes a bit of thinking. Now you can use whatever tools you've learned so far in year 10 and 11. You can use Carnot maps, tree diagrams, Venn diagrams, whatever you want, as long as you answer this question appropriately. So they tell you that two events, you've got A and B, are such that PR of A equals 3 and 5. So you've got a chance of A, you've got a chance of B. If A complement denotes the complement of A, calculate the probability of A dash intersection B. Now, if you understood all these notations, you can picture this. Which region am I talking about in terms of the units, in terms of the Venn diagram? You can visualize it as a Venn diagram. You can use Carnot maps if it's easier for you to see as a table. You can use tree diagrams if you prefer that way. I can't see it as a tree diagram. I see it more of a Venn diagram. And the first question is probability of A union B. They tell you it's 3 and 4. And then A and B are mutually exclusive. I want you to have a go with this. I'm going to give you, I reckon I'll give you, what, 3 times 1.5. Let's just make it 5 minutes. Okay? 5 minutes to do this question. And the next one is similar idea. If you really understand the basics, you can do each one of these. You've got all the tools already. It's just whether you understand it or not. Okay? We need 5 minutes. So, yeah, we can fit 2 exam questions in. Actually, no. It's 23. Hopefully I can fit the second one in. If you want a head start, I'd say use Carnot maps if that's easier for you. If Venn diagram's hard for you to draw, I'd say use a Carnot map, and it's nicer and easier to see. That's a Carnot map, just in case you didn't know what I was talking about. Starting off there, filling out the regions and points. Can I just quickly get a show of hands who have an idea of what they needed to do? Show of hands if you have no idea. Okay, cool. Let's see if I'm just going to lead you onto the idea. Carnot maps, and obviously, why did they give you that piece of information? Well, we know that A union B is the same thing as saying together A and B minus the intersection. The nice thing is you can find out the intersection from this because you already got A, you got B, and you know the total, which is 3 and 4. So you can write out an equation. You can say 3/4 equals to probability of A, 3/5 plus a quarter minus probability of A intersection. Oh, whoa, what happened there? A intersection B. So you can rearrange that equation, find probability of A intersection B. If you can find A intersection B, then you can find probability of A dash intersection B, which is this region. Okay, so the key part is how to find that spot. Which, if I show you the answers, there you go. So they rearranged it. They found A intersection B is 1/10. So you got your 1/10. And they've laid it out differently to me, but they still have A dash B. So they're trying to find this section here. And obviously take the total minus 1/10 and you get that section that you wanted. Okay, so it's 320. Anyone finished off A? Did you all get to 320? All right, cool, good. And the second part, so this one, sort of a nice distribution, about, just about 40% of them got the full marks, which is interesting because to me it's a very simple, straightforward question. And then part B, the only thing you had to understand was mutually exclusive means that the two events have nothing in common, which means the probability of it occurring is 0. So you know that intersection 0, and therefore you can find out that. Okay? Now, for the last, and that one was like a 50-50 depending on some people getting it, which is interesting again. Such a simple concept. Yeah? Here we go. Last question. See if you can solve this. I think this wasn't done well at all. It's a very simple question. Use the tools, either tree diagram, Venn diagram, Carnot maps, whatever you want. 3 marks. 2008. Question 8 again. You don't need discrete, continuous, or binomial theorem. You can just answer this question based on what you've learnt in year 10 and 11. So lay it out logically. Think about what the question's asking. You got 3 minutes before the bell goes, and I'll show you the answer. Probably use a calculator if you want. I'll highlight the key word just so you can put your focus on. I don't know if that was an obvious part, but that is your key part to answering the question. Got about a minute left. Now, I'm just going to quickly show you. The keywords were that to solve the problem, but at the same time not be neglecting this idea that they went to Chino on one Friday already. So that's the first starting point. But the point is, most students would, and this is the assessor's reports, they're saying that most students drew a tree diagram. Yes, if that helps you, draw it. I don't really care, as long as you can solve the problem. So if you drew the tree diagram, this is what you got. Yeah, you got your Chino on this first day, and you got your next 3 events. You either went to Chino Dandy, Chino Dandy, Chino Dandy. So you got 3 separate events, but you knew the first time you went was Chino. You can write out the probability based on the description, and what you're looking for, which is the key part here, it said exactly 2 out of the 3 is Chino. So all you're really looking for is as long as you got 2 C's. Now these are the only 3 options that you could have. You could have Dandy and then CC, or C Dandy C, or CC Dandy. Once you got that, then the probability is pretty straightforward. Follow your tree diagram and multiply the tree points and add them all together. Alternatively, what they're suggesting is you didn't have to. If you really thought about it, you've only got 3 options. That wouldn't have been the best approach to do. Just do CCD plus CDC and DCC. If you read the question, those are the only 2 parts. You didn't have to draw a tree diagram for that. And you can solve that. And the only thing is being wary, the first C is 0.4. Because you knew you started off with C. Okay? But that is your question. That's your VCAR question. So I hope that you just pay attention to that. It's very simple. Stick with the basics. Learn the basics well. Okay? But please pack up. It's recess now. And I'll see you on Monday for more discrete probability.